grade 11s, welcome to today's math show. Today we have a special revision lesson on exponents. We have selected highlights of lessons shown earlier in the term to help you revise term 1's work. Please post all your questions and comments on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision. Don't forget to download today's show notes on learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with our lesson.
So let's get to 1. If we're given that a is the fraction 3 to the n minus 4 divided by 6 to the n minus 2 to the n plus 2, how would we simplify n? And I'm just going to edit this slightly because this numerator should actually say 3 to the n minus 4. And while I'm on the topic of rewriting things, grade 11s, you need to use 2 of your blue lines in your book. I'm trying to prepare you for that final grade 12 examination as well. Use 2 lines for exponents. If you only use 1 and you try and draw a fraction line, then your exponents become very squashed, and this is what happens. You actually see a 3 as a coefficient and an n as a literal factor rather than n as the exponent. So we need to really use 2 lines and make sure that we can see those exponents clearly. Now, if you look at this question from the 2 that I gave you in the previous segment, what would you notice when you analyze and you look at it and you scan for the important issues? What is it that you see? Straight away, we notice that it's got terms in the numerator, it's got terms in the denominator. So I'm going to factorize. So I'm not going to use my laws for my exponent just yet. I'm going to factorize. And that prevents me from getting into the trap of saying 3 goes into 6. Because the most common error that grade 11s do is that 3 to the n divided by 6 to the n is that they say 3 goes into 6 twice. And that n goes into n, and we've got this floating 2. And that certainly is not true. You cannot divide base by base. Cannot split the base and the exponent. So we cannot divide base by base or exponent by exponent. Okay, so that is the greatest mistake, the most often mistake. If you ask your friend to do that, you'll see what they do with it. Okay, so the only thing you can divide is if we have 3 to the n divided by 3 to the n. So we've got the same base and the same exponent. Then we're dividing the power by power. So you can divide power by power. In other words, the base is the same, the exponent is the same, then I'm dividing the whole unit. I'm not splitting it. I'm not saying the base divided into the base. It's the whole unit. Now, you've been doing it ever since you were in grade 1, when you were dividing 6 by 3. That 6 was to the power of 1, and 3 was to the power of 1. So, in effect, you were dividing 2 numbers that had the same exponent. So that's what we're doing here. We're making sure that the exponent is the same before we can divide. But you can never, ever divide just base into base when the exponents are different. Okay, so now we're going to simplify this a, and we're just going to go down a little bit. Where's my page? How do I go down on my page? Oh, there we go. Right, so my question is this. A is 3 to the n minus 4, and I'm dividing it by 6 to the n minus 2 to the n plus 2. Grade 11's, our job is to try and get same base, same exponent in order to be able to factorize. So, if we look carefully, analyze. We've got a 3 to the n. We can't do anything with it. Here we've got this term with a 2 to the n plus 2, where we could actually split this because the sum of 2 exponents from your exponential law comes from the splitting up of your exponents into their bases. So when you have the sum of exponents, you actually have started with a product of two powers where the base is the same. So if I go from there to there, what would I say? I'm multiplying, same base, so I add my exponents. So you're interchanging. And why I like this format is because when you factorize, you must have base and you must have exponent. Now, that's also okay because that's base 2. If I look carefully at this term here, it's a 6. And a 6 is made up of 2 times 3. So any work around exponents, we like to reduce our number of bases. We've got a 3, we've got a 2, we've got a 6. But the 6 can be written in terms of 2s and 3s. Every number in our number system can be written as the product of primes. So we were going to take any number that is not written as its prime bases into primes. So 6 would be written as a 3 times a 2. And we're then raising it to the power of n. What is the law around product? Because remember, they're product laws. 3 times 2 to the n is the same as 3 to the n times 2 to the n. And then we have this fraction, 3 to the n minus 4, divided by 3 to the n times 2 to the n in the denominator, minus 2 to the n times 4. And now we'll see, in the numerator, there's nothing I can factorize. But can you see what's happening in the denominator? Is that we've got this common 2 to the n. And look what I'm going to take out when I factorize. Same base, same exponent. I don't split. I don't take away bases and say they're common. You cannot do that. You're breaking a number into something that it is not. So we now have that common factor. So we can say our numerator, I can't do anything with it, but our denominator I can. I can take out that common factor 2 to the n, and I'm left with, taking out a factor means I'm dividing by that, so that becomes a 1, so I'm left with a 3 to the n. And I take that out, so I'm dividing by that, so minus 4. Grade 11s, I hope that when you factorize, you actually say 3 to the n times 2 to the n. If you're dividing about 2 to the n, that goes in there once, and so we are left with 3 to the n. So when you multiply it back, you're going to arrive right back at that one. Can you see what you now have is that in the numerator, you've got 3 to the n minus 4, which now divides into that. So we're left with, that goes in there once, so I'm left with 1 in the numerator, and I'm left with 2 to the n in the denominator, which, if I had to rewrite, would just be a half to the n. Notice that 1 to the n would just be 1, so that's where that 1 comes from. But be aware, grade 11s, you wanting to be good on your speed and accuracy with this work, so that means exactly the same as that. I'm making an issue of that 1 over 2 to the n because you're going to sketch it in your graph section. Remember, it's an exponential. You sketch exponential graphs. So you will be sketching that 1 over 2 to the n, which is the same as a half to the n. Okay, so let's now see what was originally part B of that question, was to rewrite it, the answer, as in this format. So we now have A equals a half to the n. And the question said, please rewrite this as in that format. What would it look like? Okay. We now have an exponential format. And how would we write it as a root? We would take the root on both sides. So if I have A equals a half to the n, and I now take the root on both sides. I'm going to take the root n on both sides. Then when you take the nth root of a number, you undo the root. So root of n would be just equal to a half. So that value was just equal to a half. So remember, the n stands for the nth root, and in order to take the nth root of a, we would have to take the nth root on the right hand side as well, so we would then get just a half. Right, so that would be our first little question for the afternoon. Okay, let's work with some surds. We haven't done any surds yet. We've been given a rectangle. So this length here is equal to that length. And that length is root 5 plus 1. And we've been given that length and that length. They're the same. And since it's a rectangle, that's root 5 minus 1. We have that's a right angle. So it's a rectangle. I've just put in the properties of a rectangle on it so that we can see what each of the lengths are. We would like to calculate the length of the diagonal and leaving that answer in surd form. The diagonal goes from vertex to vertex. So our job is to find out what is x. It doesn't have a length, so let's give it x. And we need to leave the answer in simplest surd form. Okay, since it's a rectangle, we've put in the properties. We've got a right angle, so this x length is now the hypotenuse of that right angle triangle. So to find x squared, we would now have the one length, which is root 5 plus 1 squared plus root 5 minus 1 squared. Now we're working with the surd. This root 5 is known as an irrational number. It's known as a surd. Surds operate with the same laws. They are governed by the same laws as algebra. So we would get like surds if they contain the same surd value. Or we would work with root 5 times root 2 as root 10. You would multiply the two surds together. So the relationships that you've learned in algebra apply to surds. So now that I've got to square this bracket, we're going to get squaring a bracket means the square of the first, and square root of 5 times square root of 5 would give me the square root of 25, which in rational form would just be 5. Then remember that when you're squaring a bracket, you've got the doubling up of the product of the two. So it's root 5 plus root 5, which would be 2 root 5. And then we've got this plus 1. We're also squaring that binomial. Root 5 times root 5 would just be 5. Double would be minus 2 root 5, and we've got this plus 1. So we have a 2 root 5 minus a 2 root 5, which is 0. And we've got a 5 and a 1, which is 6. 5 and a 1 is 6. So x squared is 12. So let's just get our work back. Okay. X squared is 12. So x is equal to the square root of 12. How do we get surds to be in simplest form? You need to extract any square root, any perfect squares that you see in those numbers. So the square root of 12 is the same thing as the square root of 4 times 3. So the square root of 4 times the square root of 3 would now give me 2 root 3. And this version of root 12, where part of the number is rational and part of the number is irrational, is what we call a simplified surd form. To get a surd into its simplest form means you're going to rewrite the number without any perfect squares in them, because the perfect squares become rational, and that makes it into simplest surd form. Now you will find that you're going to be adding 2 root 3 to another 2 root 3, for example. So if I had a 2 root 3 and I added to 5 root 3, we would call these like surds because they contain the same surd portion. So that the rules for algebra would be we would add the coefficient, so we would get 7 root 3. So once we have got every single number into simplest surd form, we would then just add like we would add in algebra, like we would subtract, divide, and multiply as well. The only new thing about irrational numbers is that if I was squaring root 12, then I would say that that is root 12 times root 12. So I would get 12 12s are 44. I would get the square root of 144, and that would just be equal to 12. So when I take an irrational number and I multiply it by itself, I get the rational version of that number. That's the only law around irrationals that you would have to look at. Okay, so just to check that we've looked at the diagonal and we've given it in simplest third form. Right, grade 11s, let's see the last little question in the segment. And that is, how do you simplify an expression that contains, watch it carefully, plus minus plus? What are you going to do, grade 11s? By this stage, you must be able to tell me what you would do when there are sums and differences. But I also notice that I've got a root x, but I've got an x to the half in the denominator. In that case, we are going to rewrite our surd into exponential form. You will not write that surd into exponential form if you've got other surds lurking about. But in this case, everything's got an exponent except that little root x. So the first thing we're going to do to it is that root x means the same thing as x to the power of 1. The root is 2. Remember, a square root doesn't have a 2 there, but the first root that we get is the square root. So we actually have 2x plus 7x to the half minus 15 all over x to the half plus 5. Now, grade 11s, you must also be a little bit smart about how questions are asked. If I'm asking you to simplify a quotient, I'm saying, please, won't you divide that won't you divide that divisor into that dividend? Then your job as a mathematician is to say, well, that thing in that denominator must be a factor of the numerator, okay? Because otherwise, I'm not going to be able to simplify this. I must be able to divide that whole x to the half plus 5 into that numerator. So this numerator over here must be able to be written as the product of factors, one of which must be x to the half plus 5. It makes sense that that factor should be there. Otherwise, it's not possible to divide. So notice carefully that this is a trinomial where my middle term is x to the half. That is a clue for me that my first term must be 2x to the half, x to the half. Here come your powers, your algebraic powers, to be able to factorize. That x to the half times itself will give me x to the 1. So a very important tip, x to the half times x to the half, same base, keep the base, add the exponents, half plus a half. Don't get tempted in multiplying these things, which is x to the 1. So my middle term always tells me what the first two factors are going to be. Then I need factors of 15. So I need a 5 and I need a 3. And lastly, we need to think about our signs. I want to get a plus 7. How am I going to get a plus 7 out of that? I'm going to have 5 2s are 10, and I'm going to get a 3. So I want to get a 10, a positive 10, minus a 3 to give me the 7. Ah, look at it. I have factorized it, and I'm actually getting that factor in there. That's exactly what I wanted to do. I wanted to be able to factorize, because when there are terms, I need to factorize. There are no other options, grade 11s. If there are terms, I must go and factorize. I won't be able to get out of that jungle without factorizing. So in the end, we have that goes in there, and we're left with 2x to the half minus 3. So we're only left with that portion.
All right, Mindsetters, I hope you guys are enjoying this revision session. Remember, if you are struggling and need help, please post your question on our Facebook page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, so don't go anywhere. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on the page or on Twitter. Enough of the chat. Let's get back to the revision.
Right, for now we're going to do some of the examples that I mentioned in the notes. We're going to look at solving an equation with a square root. We're going to solve one where we're going to try and get the same power on both sides of the equal sign, and we're going to have one where we're going to do some factorizing. When in doubt, try and factorize when you're solving an equation. It's usually the tool that gets us to be able to find that x value we're so desperately always trying to find. But for now, let's look at how to deal with that square root. Okay, so the improve your skills section, question 1. The equation is the root of x minus 2 is equal to 4 minus x, and we would like to find what the value for x is. And we've got a square root that is already isolated. So remember, if there were any numbers, any terms, etc., we'd isolate it. But in this case, it's already isolated. So now we're going to square both sides. Don't pick and choose what it is that you want to square. We are going to take the left-hand side, everything there, we're going to square it. We're going to take everything on the right-hand side, we're going to square it. And then we're just going to apply our algebraic rules. So if you take a square root and you multiply it by itself, you're going to get an x minus 2. And if you square a binomial, grade 11s, do it all with me, say it out loud with me. It's 16 minus 8x plus x squared. Remember that you've always got your outers and your inners, and we can't forget that. The most common teenage mistake with binomial squareds is always we say 16x squared because we're missing that middle term that is so invisible. Okay, but remember there's always 3 terms. In fact, there are 4, but the 2 middle ones get added up together. And then from here, we now can find the quadratic, so it's x squared, and we've got minus 8 minus 9. And we've got 16 plus 2 is plus 18 is equal to 0. And this factorizes, I think, as x minus 6 and as x minus 3 is equal to 0. Plus sign at the end, both brackets will have the same sign, negative 6, negative 3, negative 9. Always check your work, check for accuracy, check, check, check all the time. So therefore, x is equal to 6 or x is equal to 3. Now, I said earlier that this is a section where you really build confidence because you can go back and test your solution and see that you're correct. So if we go back to the top and we test our solution, I want you to see what happens. I'm going to do it in blue. If we test 6 on the left-hand side, if x is equal to 6, then we're going to get the left-hand side, we're going to get 6 minus 2 is 4, the square root of 4 is 2. And on the right-hand side, we're going to get 4 minus 6 is equal to negative 2. So we have the left and the right are not the same, therefore x is not a solution. Okay? So even though x equals 6 is a solution to the quadratic, it's not a solution for the original equation. And then if x is 3, let's see what happens if x is 3. The left-hand side is now equal to 1. And the right-hand side is equal to 4 minus 3 is equal to 1. We get the same thing on both sides. Therefore, x is equal to 3. So at the end, when you've done your testing, therefore, x equals 3 only. Solution. Okay, so what we've done is we've created an equivalent equation by squaring both sides, but in finding the solution to that equation, we find that only one makes the original. Remember, the original did not have the green portions to it. It just had the white portions. So we would have to go back and test in the original. Right, what's next? Okay, we've got question 2, which says solve for x. And I'm just going to, on the side here, just rewrite it as 3 to the power of x squared minus 1 is equal to 27 to the power of negative x divided by 3. Okay, now let's analyze. What do we see? We have a left-hand side with a 3. We've got a right-hand side with a 27 and a denominator of 3. But we also recognize that 27 is a power of 3. So this could be written as 3 to the power of negative 3. And just by analyzing that, we can see that these powers over here can be written as 3 on the right and powers of 3 on the left. So if the exponent is unknown, we try and have the same power on both sides. Sometimes that's not possible because we've got more than one term. And then in that case, we could maybe factorize as the notes in your previous section. Okay, so it definitely is one of the cases where we can see that we can create the same base on both sides. So in our next step, we could say, therefore, x squared minus 1 is equal to 3 to the power of negative 3x divided by 3 means minus 1. So I've got same base on either side, 3 base 3, and therefore I say same base equate exponents. Okay, and we therefore have x squared minus 1 equaling negative 3x minus 1. And now we have an equation on the exponents that we're solving, and we can take it from there and solve the quadratic. So we have an x squared minus plus 3x, and then this negative 1 comes across. A negative 1 plus 1 is 0, so that's just equal to 0. And how do we factorize a quadratic where there's a common factor? We take out the common factor, and we're left with x plus 3 is equal to 0. So we then get x could be 0. Remember to connect these statements. They're not loose statements. X equals 0, or x equals minus 3. Now, with any of the exponential equations, we go back and test. Does it make sense? If x is 0, then I'm getting 3 to the minus 1. If x is 0, I'm getting 3 to the minus 1. So that's a solution. And then if x is minus 3, I'm getting a 9. Negative 3 squared is 9. 9 minus 1 is 8. I'm getting a 3 to the 8. And here I'm getting a 9 minus 1, a 3 to the 8. So both of the solutions are valid. Valid and valid. So we're just validating our solutions, because sometimes we get values that will create statements that are actually invalid. Okay, then the last one, and we were looking at question 3, is to solve for x, where 3 to the power of x minus 3 to the power of x minus 2 is equal to 24. In this case, I immediately notice that I have a 3 to the x and I've got a 3 to the x. It's just hiding. This 3 to the x minus 2 is actually built up of the sum of two exponents. And grade 11s, where does the sum of two exponents come from? It comes from two powers. I was almost going to say superpowers, but they're not superpowers. But two powers that have got the same base. So I can split that into two powers. That's what it means. It means that each of those exponents is coming from the same base, and we are multiplying those bases. So this is an exponential law where you often go from there, from the right-hand side, to the left. And now I'm asking you to go from the left to the right. I'm asking you to expand so that you can actually pick out what the common factor is. So we now have, if we have to expand this, I'm going to have, let's see, a rewrite. So it's 3 to the x minus 3 to the x times 3 to the negative 2 is equal to 24. The biggest error and your biggest temptation with this question is to actually say that if I had to take out a 3 to the x as a common factor, that I would be left with a minus 1 to the negative 2. That's what people often do, is they take the base out, they take the exponent out, and they have what I call floating exponents. They don't know what to do with them. So in exponential work, never ever take out a base and exponent if that base and exponent hasn't been isolated. So isolate the base and let's isolate the base and the exponent for a common factor. Okay, so notice how I'm not taking out a 3 to the x, and I don't know what to do with that -2. I've actually first expanded it. If you have a sum of exponents, what does it mean? It means that each of those exponents belongs to its own base. So go and write it down as its own base. Now I have a common factor. Can you see? It's base and exponent, base and exponent. If you take out an exponent, in grade 11s, for those of you who have not yet mastered how to factorize and take out a common factor, to take out a common factor, what operation is that? When I perform a factorizing of a common factor, what operation am I performing? I'm performing a division. So what you're doing is the converse of your distributive law. You're actually doing the converse. You're doing the opposite of the distributive law. So if you're doing that in reverse, what would that be? If you're multiplying in, you need to be dividing to take out the common factor. So divide 3 to the x by 3 to the x. What do you get? You get a 1. Okay, you don't get a nothing. And then you're going to have a subtraction sign. And a 3 to the x, you've taken that out, so you're getting another 1 times a 3 to the -2. How much is 3 to the -2? 3 to the -2 is 1/9. It's equal to 24. So now you've got this bracket with these two terms, and grade 11s, you must check the accuracy of your work when factorizing by remultiplying. So that 3 to the x being multiplied by 1 gives me that, and that 3 to the x multiplied by that gives you that. Another tip for factorizing is if there are two terms that you're factorizing, there must be two terms left in the bracket. So many of you will just write down one term. That means you're not verifying the quality of your work. You're not double checking that your work is valid. Okay, so therefore, we've got a 3 to the x that we're multiplying by. A 1 minus a 9th would just be 8/9. And we've now got that that's equal to 24. What do we do with the 8/9? The 8/9 is being multiplied by 3 to the x. What do I do as an inverse operation? I would divide by 8/9 on both sides. So I would get divided by 8/9 means times by 9/8. And if we just keep going, we get a 3 to the x is equal to 8 into 24 is 3, times 9 is 27. So I'm going to already write it as its power, because that is a neat equation. I have the same base on both sides. If my base is the same, therefore base is the same, therefore exponents are equal, and x then must be equal to 3, because there's my exponents that I can now equate. Now, to make you think a little bit, grade 11s, you've got 3 to the x equals 3 cubed. What happens if you've got 2 to the x is equal to 3 cubed? What happens when the base is different? Because in maths, as a mathematician, you must always be asking yourself, we're using this law, but what happens if something within that law had to change? How do I adapt to it? Well, for now, you'll have to put that on hold. You'll have to put that in your window that you keep open until you do what we call logarithms when you get to grade 12, because that will be our tool to be able to solve that. So for now, if you had to get something like that, you would say, only in grade 12, okay? For now, you should be able to get everything onto the same base, although some of you may be saying to me, yeah, you think that you could do this, because this is equal to 27, and you'd be looking at which of your powers of 2, do you know, are closest to 27? And you'd be saying something like this. 2 to the x you think would be between 32 and 16, because that would be 2 to the 4 and 2 to the 5, and so 2 to the x would lie between 4 and 5. And so you could estimate, you could give a very broad estimation, but at least you would know that it would be between those two integers. So you could be getting a question like that, even though you don't have that tool to finally catch what that x value is. You could create some kind of estimation. So for now, we want the same base on either side, and we want to be able to equate the exponents.
I'm sure you've seen the walk together photo on our page. Please post a caption and like the captions that you think are best. The 3 captions with the most likes will each win a pair of tummy tackies. We'll post the winners on Friday, so get to liking and get all your friends to like too. Now it's time to take a break, so don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and for the holidays to start. This year we bring you revision sessions from term 1 from the 28th of March till the 6th of April. These will be repeats of all the Learn Extra live shows from term 1. These programs will run from 9 a.m. in the morning till 7 p.m. at night. Go to our website learn.mindset.co.za for all the details. But for now, let's get back to the revision.
We're going to start off by completing the square on this equation. And we need to leave our answer in simplified surd form. So if you're completing the square, the one factor that involves getting it correct is that the coefficient of x squared must be 1. So if I look at the current coefficient, it's -2. So I'm therefore going to divide by -2 on both sides. And so I get x squared minus 6x plus 4 is equal to 0. Let's just check that. That's negative 2x squared, positive 12x, and negative 8 is equal to 0. Once you've got the coefficient of x squared as 1, we're now going to take just the binomial. So we're going to take, what are these little things doing here? Where did they come from? Right, so we're going to take just the square term and the linear term, and the constant, we're going to take it, we're going to eliminate it. So we're going to get rid of it by adding negative 4 to both sides. Now, the next step is where the completing of the square comes from. We're going to add a constant to our quadratic. And the portion that we're going to add is half the coefficient of x, and we're going to square it. So if I take half of negative 6, that's negative 3, and if I square it, I'm going to get plus 9. And this is an equation, there's an equal sign. So what I do to the left, I do to the right. So coefficient of x squared is 1. And then this is where the portion where I complete the square. In other words, I'm trying to get the trinomial to become a perfect square. And the way that it becomes a perfect square is if I add half the coefficient of x and I square it. So now I have got this trinomial, x squared minus 6x plus 9. Grade 11s, I'm saying completing the square because ultimately that trinomial must be factorizable. It must factorize into a binomial that is squared. It better, otherwise we are wasting our time here. So it factorizes as x minus 3, and we're squaring it. Does it work? Negative 3x is negative 6, and negative 3 times negative 3 is positive 9. So that's equal to 5. Okay, once I've got my squared value, I now have this situation where if I take the root on the left, I get minus 3. Or if I take x minus 3, I can equate it to, if I take the root on this side and the root on that side, I'm getting root 5, but I could also get minus root 5. So this is something that you've brought from grade 10, and that is that if you've got x squared is equal to 4, let's look at a perfect square example, then the quadratic equation has two solutions. It can be 2 or it can be minus 2. Because if I substitute 2 and I square it, I get 4. Substitute negative 2 into my quadratic, I also get 4. So a quadratic has got a possibility of two solutions, one a positive, one a negative. So I'm doing the same thing, but because I've got a non-perfect square, I've got 5, I'm going to look at x minus 3 is 5, or x minus 3 is negative root 5. And then to end it off, I can now solve for x and say that it's 3 plus root 5, or x equals to 3 minus root 5. Okay, and I would really only do that if I was asked in the instruction to complete the square. Otherwise, I know that this method is there to help us prove the quadratic formula, but I wouldn't ordinarily use it. I would stick with the quadratic formula. It gets to the solution much quicker. Okay, so just to recap, if you do not make the coefficient of x squared 1, you are stuck, you can't go anywhere. So that's what we did first. Coefficient of x squared is 1. Then we've added the most important part, this green portion. We've added half of negative 6, which is negative 3, and we've squared it, so we've multiplied by itself, which is 9, but we don't want to unbalance the equation. So if we had to take away the 9, we would still be getting the same equation. It's still equivalent. And once we've done that, we can now factorize into the binomial squared. So at this stage over here, we have factorized into, why do we say that this is a perfect square? Because it's made up of two factors that are the same. They're exactly the same. So x minus 3 times x minus 3, it will give you the area of a square, and your area of the square is x squared minus 6x plus 9. Okay, and then you can just solve for the x once you've taken both sets of solutions. All right. So that is completing the square in a nutshell. Now,
okay, Dina, before
yes.
you move on that question, I seem to be having some questions from the mindsetters.
Yes.
They say, why did you plus the 9y? Don't you just divide by 2 both sides?
We did divide. Let's go over it.
And others say, why don't you divide by minus 2 both sides?
We did divide by minus 2 on both sides. If you look here, you've got 0 divided by negative 2 is still 0. So we did do that. Grade 11s, we've divided everything by negative 2. We've divided that term by negative 2, we get x squared. We divided that term by negative 2, we get negative 6x. We've divided negative 8 by negative 2, we get positive 4. And we've divided 0 by negative 2. And 0 divided by negative 2 is still 0. So we have divided.
And quickly, one last more. How did you get your 9? That's
Okay,
where they
I've
got
set it in the
lost.
green block, and I've made it green so we can see how we did it. I've taken a half of the coefficient of x. So if you look at the x term, its coefficient is negative 6. So I've taken the negative 6. Let's just put it in nicely over here. So we've taken a half of negative 6, and we've squared it. So that's negative 3, which we have squared, which is 9. So the green portion is exactly what we've done. Okay.
Awesome.
Yeah, I'm glad that you're asking, because it really is a foreign concept. You haven't done anything like this before. So it's important to just go over it and consolidate to make sure that you really got it. So it's great for those questions. All right, now, if you look at this equation, 2x cubed minus 5x squared minus 11x equals 0, that's a very interesting question, because I've been talking to you about quadratic, and the word quadratic in English may mean nothing to you, because this word comes from the root, the Latin root, quadra, and the quadra is actually a square. in some of the European language, you say a quadrado. And that is a square. So for those in the world that have got Latin as its root word, the quadratic equation really means something. They can identify with a square. In other words, that power of 2. But for us in South Africa, where the language doesn't really build up from the Latin, you really have to really memorize and make it part of your bloodstream that a quadratic equation means that the highest power is 2. The moment I come to this equation, the highest power is not 2. The highest power is 3. So what are we going to do with it? Well, we do what we do with all nonlinears. We try and see if it's factorizable. So I look at all 3 terms and I ask myself, is there a common factor in all these 3 terms? Yes, there is. There is an x. So I'm left with a 2x squared minus a 5x minus 11 is equal to 0. So now I'm landing with a very interesting trinomial here, plus I'm landing up with this factor. Now remember, in our notes, we said that if you have an a times a b times a c, and you're equating it to 0, then it means that a is 0, or maybe you can have b as 0, or you can have c as 0. What we don't want to do is we don't want to take a term onto that side, because then it makes it impossible to solve. Then we've got no way of being able to solve. So we now have this factor times that factor. So we've got x can be 0. And it's true, isn't it, that x can be 0, because 0 minus 0 minus 0 give me 0. So x can be 0. Or we've got 2x squared minus 5x minus 11. So we've got a really interesting case here of whether this particular quadratic is this factorizable. And some of you may say, well, yes, you think that 11 and 2 will factorize. Well, I'm beginning to doubt whether it does factorize. So because I'm doubting myself, I'm going to automatically use the formula. But before you do that, what is a? A will always be the coefficient of the x squared. B will be the coefficient of x, and c will be anything that's not attached to the x squared or the x, which in this case is minus 11. And now I will use the formula, write it down every time as negative b. You can have the positive or the negative of this square root, b squared minus 4ac, and you're dividing everything by 2a. And now we can substitute. B is negative 5, and in other words, we've got a negative 5 squared minus a 4 times an a, which is now a 2, and the c, which is negative 11. And we're dividing that by 2 times 2. So all I've done is I've substituted those ABC values into the formula, and simply because I want to illustrate that if you're not sure if it's factorizable, you can go ahead and just replace the coefficients, and it gets us to this. Plus or minus the square root of 25 plus 88. So it looks like it's 113 if you check my arithmetic. So we've got 25 and 88, 113. And that really is the 2x values. Now notice that there are 2 x values inside here. There's an x of 5 plus that root over 4, or there's an x equals 5 minus that root over 4. So there are actually 2 values. And we've got the other one that we've left behind because it was so quick. It took us so quickly to find out, and that is that x can be 0, or x can be those 2 values as well. So that cubic actually has 3 solutions, and that's the maximum number that a cubic can have. Now notice, the quadratic, because it's square, it doesn't have 3 solutions. It only has maximum of 2. And we'll see in our next question, when is it that quadratics have 2 solutions, 1 solution, and 0 solutions? We're going to do that later on when we discuss the nature of roots, but let's have a look at an example that illustrates this. Again, the question is to leave the answers in simplified third form where necessary, and we are going to be solving for x. And we are given 3 scenarios. We are asked to find x in the following equation. And if we look at it, what's its highest power? So we can understand its nature. It's a quadratic, it's power of 2. And then we'd like to know for these various values of k, what is x? So the first one would be, when is x minus 4 squared equal to 0? Now, grade 11s, it's obvious. When is that multiplied by itself 0? Well, if we had to write it out, this is what it would mean. When is x minus 4 equal to 0? Or when is x minus 4 equal to 0? Okay? It's following the 2 key properties of quadratics. It's already equated to 0, and it's factorized. So in that format, I have my solutions. X can only be equal to 4. So it's only got one solution. Now, the next one is interesting, because if we write it down as x minus 4 squared is equal to negative 9, then just by writing down the equation, there's a contradiction here. This value is always positive. This value is negative. So there is a contradiction here. I am not able to find an x so that this is true. This is actually going to be a non-real solution. So I would say no solution in the real numbers. Okay, I can find a non-real one. Okay. So what about if we have x minus 4 all squared is equal to 5? Okay, notice that that one was equated to 0, this one isn't. So we'll need to do some manipulation and getting it to 0 first. So that's a negative 8x plus a 16 minus a 5 equals a 0. And then we get an x squared minus an 8x plus 11 is equal to 0. And now I can see there's no factors of 11 that add to give me negative 8. So I'm stuck. I need to use the formula. So it's 8 plus or minus the square root of 64 minus 4, a and c. And I've got it all over 2. So I've got x equals to 8 plus or minus the square root of 64 minus 44, which is just 20 over 2. And the question was to find it in simplified third form. So that's 4 times 5. So it's 2 root 5 divided by 2, which is a 4 plus or minus root 5 divided by 2, which is just 4 plus or minus root 5. Notice they asked for simplified third form. So that's what we're doing, is we're not using the calculator. But if you needed to, you could very easily use a calculator. So we've looked at quadratic may have 2 solutions, a quadratic may have 1, and a quadratic may have no solutions. So maximum 2, sometimes 1, and sometimes no solutions in the real numbers.
We've come to the end of our show. Thank you so much, Mindsetters, for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get your notes and to watch the videos from the term. Goodbye.